Hi all, let us explore more about electric potential. What is meant by electric potential? It is about work done to bring a positive charge from infinity to that point, or work done per unit positive test charge from infinity to that point. So we have two options to define this electric potential. Let's say we place this point x from point charge of q at this distance r. So for these two like charges, we can see that force of repulsion is away from positive test charge, whereas the applied force is attracted to point charge q. Applied force always attracted to point charge q. So the work done by the applied force and work done on the electric force. By considering electric force or work done on electric force, we can use the mathematical concept to derive electric potential. The negative here shows the work done on electric force. By using the process of integration on both sides, we can derive one solid formula, and is about work done in bringing this positive test charge from infinity to that point, so called x. And that work done is about k and the product of point charge q and test charge q divided by the distance r. Everyone knows that electric potential is equals to work done per unit positive test charge from infinity to that point, So by substitute the work done into this formula, and finally we can get one solid formula for electric potential, which is equals to k q over r. And we're going to use the same technique for negative point charge. Now we can see the electric force and the applied force is attracted towards negative point charge. As I mentioned earlier, applied force is always attracted to point charge, whereas for electric force, because of these two charges are unlike charges, this force is attracted to point charge q, which is negative. And it is crystal clear why the electric force is attracted to negative charge, because these two charges are unlike charges. So we're going to do the same mathematical process, and finally the electrical potential V is equals to negative kq over r. Let us try to attempt this STPM 2005 question to strengthen up your confidence. The diagram below shows 2 points charges negative 1.2 microcoulomb and 1.0 microcoulomb separated at a distance of 0.6 meter. Point O is the midpoint of the two charges. Calculate the electrical potential at point P, which is 1.2 meter vertically above O. To solve this problem, first we have to consider the number of charges surrounding this point P. So the number of charges is only two. One is at B, another one is at C. The next step is find the electrical potential from point P to the charge 1 and point P to the charge 2. And it is about VAB plus VAC. So we're going to substitute all the possible values into this equation. We know that electric potential is kq over r. So for AB, k qb over distance from A to B, plus for VAC, k QC, distance from A to C. Unfortunately, the distance of AB and AC is not given. So we're going to use the mathematical terms like theorem Pythagoras to find the distance of AB and AC, which is equals to 1.24 meter. For electric potential, negative and positive sign are dependent. We have to consider these signs in the calculation part. By substituting all the possible values accordingly into this equation, we can manage to get electric potential P is about negative 1451.6 volt or negative 1452 volt. Thank you for watching this video. Thanks a lot and thank you to the Lord.